Science Giants. We are going to do investigation 3.3 together, which is testing how resistance affects electrical devices. So I have built the circuit that is shown in a schematic on your lab sheet. Now, the first thing you're going to do when you have your lab sheet is you're going to make a prediction, and you're going to tell me what you think will happen when you change the amount of energy supplied to the fan in regards to its power. So how will the power change when you change the amount of energy? I'm going to write that in a complete sentence. Then I will build the schematic like so. And then I'm going to use the voltmeter and ammeter to collect data. While the fan is running, it transforms electrical energy into other types of energy. The amount of electrical energy supplied or used each second is called electrical power. And power is found by taking current and multiplying that by the voltage. So I have my ammeter that's going to tell me current, and I have my voltmeter that's going to tell me the voltage. So I will multiply those two together in order to find what the electrical power, which is measured in watts, is for the circuit that I've built. So the first thing on my lab sheet is one battery. So I am going to connect it like so. And remember, when you build circuits, some safety expectations are always start with an open switch. So you can see here that I've got my switches open, and I'm not doing anything with my connection until I have everything put together the way I want it, checked my negatives and my positives, and then I can close the switch to see if I have my circuit built correctly. So I will do that with one battery. And my fan starts moving, and I'm going to collect both quantitative and qualitative data. So my quantitative data is I'm going to read my meters and record what my milliamps say and what my voltage says. And I'm also going to collect qualitative data about the fan speed. So I'm going to write down that I feel like this is a medium fan speed. And I'm going to write down for one battery, the current on my ammeter says 250. And my voltage says 1.1 volts. Remember, when you are calculating power, multiplying current times voltage, you first need to convert the milliamps into amps. So I'm going to take my milliamps, which is 250, and I'm going to divide that by 1,000. So the number that I will multiply is actually 0.25. So I'll take 0.25 and multiply that times 1.1 volts to calculate what the power is in watts. After I've done that, I'm going to change the amount of energy supplied to this circuit. So I'm going to open up my switch, and I'm going to add a second battery. Then I'm going to close my switch, and I'm ready to record. Instantly, I can hear and see that my fan is moving even faster. So I'm going to write down my qualitative data is the fan is on high. My current is extremely high. It's actually showing over, let's see, it's about right at 500. And my voltage says 1.8. So I'm going to take my milliamps, 500, and divide that by 1,000. So I'm going to get 0.50, and I will take 0.50 and multiply that by 1.8 on my data sheet in order to find out what the power is. So I'm going to do both of those right now. .25 times 1.1 is 0.275 watts of electrical power. My second data point of two batteries is 0.50 times 1.8, which is going to be 0.90 watts of electrical power. So I can see that as the amount of energy supplied to this circuit changes, the power changes as well. Increased energy equals increased power. So then I'm going to answer the last two questions on my lab sheet, A and B, about explaining your thinking and making a prediction, lastly, about resistance. So based on your understanding of Ohm's law and how power is calculated, would the power used by the fan be greater if I were to add into this circuit a 10 ohm resistor, or if I would add into this circuit a 15 ohm resistor? So you're going to tell me what would happen to the power if I added a resistor in here and I had either a 10 ohm resistor or a 15 ohm resistor. You're going to make a prediction and explain why you think that is so.